Here we go. It's around 8:30, 8:40, 23rd of October, 2025.
Those two are staying right the same as they always have been. Now this here, you know, I don't know about, so.
Yeah, but I was crudely measuring.
You guys got a busy day?
Yeah, I'm gonna do 5 dams today.
Oh my God.
Yeah.
Today's damn day. Yeah.
You want my picture, Glen?
Sure. And I'll put you in the report. You can prove you were here.
Yeah.
Yeah, yeah.
Yeah,
A couple weeks.
Aren't there two valves?
Yeah, there's one down at the toe as well for the pipe that's actually in the dam. I don't know if that one is operable. I don't think.
No.
That's been shut.
Yeah.
That's probably, that inlet or outlet, whatever, is probably buried under 30 feet of silt by now.
So is this thing leaking?
Yeah, those gates, they're never a perfect seal. They
Okay.
always leak a little bit.
You've always been nice.
All right. Waiting on Marilyn.
What size pipe is that? That 36?
24, I believe.
24? Yeah,
Might be able to look at it.
bigger over here.
Five by 6 drop inlet. These are 36 CMP.
Marilyn, how you doing? Don Likens.
I'm well. How you doing, Don?
You're looking great. I'm recording you. Hope you don't mind. You are
Well,
Don't record anything with me in it, and don't put it on YouTube either.
too late.
Well,
Too
anything
late.
in me you need to edit out.
No. Go sit in your car then, dude. Too late.
Everything we do is public record.
Yep. If you're wanted in 3 states, too bad. (23rd of October, 2023, 2025). That's Marilyn. That's Glen from the state.
I got one up there. I got a patch. Balls. Yeah, it's epoxy stuff I put in there. See where it's cracking up there.
Have you got grass growing where it should
Like a
be?
drought with epoxy in it. Winter time, clean it up. Concrete underneath seems nice and sound though.
I can pick up some. I got that last amount.
Should we patch these potholes Are they okay?
Yeah, he said they put epoxy modified grout and smooth it off.
Right.
What's-
That's what we've done in the past.
When's the last time we did these, Bruce? You do 'em?
Yeah.
When's the last time we did 'em?
I think I put this in last, I don't know, last fall maybe.
Okay. Looking at the spillway and the cracks.
Yeah, little cracks in the concrete need to be filled a little bit. Some
Right here on the spillway.
All right.
Walking down?
This is what I do.
Not sure I want to walk up there.
You want an arm?
No, I'm good.
Okay.
So we're thinking it's in the first 6 or 8 feet of water, over that. That was both of those have been since 2018. This section right on is put in 2017. Mr. Jim Sebring did that.
Yeah, that crack is. Just stick your foot over there for scale.
Right here.
Yeah. That's good.
This was done.
That's good.
When did this settle? When did you almost
Just this year.
So after that, like in April when we had a lot of that rainfall and
But you can see the new part. This new was 2017.
so that is obviously coming through that rock strata
Right.
in this spillway area because this is the dam. You know, this is not the dam. This
Right.
is natural.
Earth and, yeah, this is
But what it is, when that lake come up, that flow greatly increased, creating that void under there. So you'll have to get an engineer in here to design a repair, which at this much with this extensive void, you'll have to remove the concrete.
Right, that's what we did last
And you'll need to explore to see how far it goes. It looks like, I would say it's limited to this area, but you don't know. You have to sound it to figure it out.
They have a spring around, comes out the hillside over here,
Yeah,
straight out of the
I
lake,
said-
and that's been trouble.
They said this one slows down when they lower the lake. So
Well, that's a lot of water rushing through there. Holy cow.
What is
yeah,
that?
y'all might not want to.
Stand on this thing.
I don't think it's gonna. It's pretty solid concrete, but it is undercut. So
So it's undercut because the water's rushing underneath the spillway.
Well, that was just
I can't reach the bottom.
better lake.
yeah, well during the April
that's
flood event, probably increased the flow amount, and that's probably what caused the void.
Really? This happened in April?
Wow, look at that void down here. Hey, this is better than McKee, Glen.
Well,
Got a hole, we can do some splunking.
We could start admission to go in this thing.
Let me know if you find my Volkswagen, will you?
it's all over here on
Jimmy,
the
hold on.
left
Move this
skirt too. It's. I don't. Does it go much further to the toward the actual spillway apron over that way, toward the draw's left?
Let's cut it like this way with it, Glen. Yeah, it goes over there quite a ways from
This looks like it's
Wow.
dropped there too.
Yeah. So basically, what you have to do to fix this is cut the concrete and remove it, and
Fill it.
just go as far as find the end of the void.
That's what we, this
And
year,
then-
this is all new from 2017.
Well,
Cut what?
Your
Cut.
engineer will have to actually design your fix, but typically you're looking at either, since there's an active flow, you would try to manage that flow with filter drains, collect it, get it away from the spillway. And then backfill here, your engineer would design a backfill system to not only fill the void, replace the concrete, but also to manage the flow.
Yeah.
Some kind of pipe or something under
Yeah,
there.
collect it and get it out from underneath there.
You don't think we could stop the flow?
thank you.
I mean, you all can try to stop the flow. There's definitely ways to stop the flow, but
My thinking is stopping that flow. We might just push it out. And
it will. Yeah, you can work and work and work to stop the flow, and sometimes you stop it, sometimes you don't stop it. Sometimes you just slow it down. It will move around because that head's going to go somewhere, right?
Yeah.
The feeling is it's here though.
One way or another, it's
control
gonna
it,
be
But-
out.
rather than
if
pushing it
you-
out somewhere where it
There's a flow here.
Yeah.
The best thing really to do, you can try to slow it down some by grouting and stuff like that, but you need to manage the flow where you know it is. So the way we do that is we use drainage systems, filters, and we collect that water. The water, as long as we can control the water, it's not a threat, right?
Yeah, that's what I was thinking. Whereas
So
if we push it out, we're going to push it somewhere
yeah,
else.
and the
we don't.
filter drain will collect the water, relieve the pressure, and it'll also keep the material from being transported out and causing voids and stuff.
That's
So,
what I'm thinking.
but you'll have to have an engineer design all that, do the gradations for the filter materials and all that, and then replace the concrete, of course. But yeah, there's no way. This size of a void, there's no way to keep from having to remove the concrete to fix it. I mean, you can't do it.
Try to drop that
Yeah,
in.
you're not going to be able.
So they can
Fill that
remove
with
remove this
gravity.
new slab from 17? Is that what you're talking about?
Yeah,
There's all these slabs right here got to be taken out.
yeah, if you got water going under it, it's gonna have to.
Yeah, well, that's all this
It'll
down
have to
here.
be cut enough to define the extent of the void.
Well, that's way back there. Damn.
Are you like working for the state? Like, are you guys able to give any recommendations on engineers or
We
anything?
don't do design. You have to contract with your own consulting engineer to design.
Are they licensed?
It's a conflict of interest.
Yeah, I think
Oh my God, Marilyn.
Yeah,
You can
the
hear it.
engineers have to be licensed. And we have to be licensed.
The only thing I can do for you is just kind of give you general ideas of what the engineer might be doing.
Oh my God, it's a river.
Ways to do it, right?
Oh, it's a river in there.
Your engineer's going to assess the site.
Gee, that's bad.
Determine what's the
Yeah, it
best
is bad. It's a big hole back
fix
there.
for your
Holy
site.
cow.
It's all very site specific. So, and like I said, we don't even know what the extent of the void is yet. So that will determine what fix is used. But it's not a threat to the overall global stability of your dam, because the dam, it's separate from the dam. The dam's over there. This is the spillway. The spillway's on natural ground. But what will happen is your spillway is not supported here, and you know it's going to continue to get worse. And eventually, you may actually have a situation where your lake level is going to drop because you've got basically an open conduit.
Absolutely, yeah. I mean, that's a big problem. Yeah. I can't imagine what this is like when lake is full. You know? Wow.
The lake's full right now.
Well, no, it's, well, I mean, when it's overflowing like this, what's this doing when it's overflowing? My God, the pressure.
It's coming full. When it's overflowing.
You don't think it gets any more? Flow doesn't increase when lake's fuller? Wow. That's like a river. Holy cow.
I wonder if that was longer and it sheared off.
Wow.
Well, that's for when they put the new in, they drill back in there. They just drilled those in, probably.
Well, that didn't help.
We'll see when you go back to build back, the proper way to do it is to, if you have a joint like this, the lower slab actually has a key that goes under the upper slab. The upper slab holds the lower slab down.
Instead, we just drilled in.
Well, and then you also have the dowels, of course, that kind of hold everything from doing that number. Water stops and all that.
Did we not put enough rock underneath there, you think?
Well, no, I mean, it would have been the virgin earth material probably, and then they laid the concrete. They probably put a drainage layer, and then they put the concrete on top of it.
You think they should have put a bunch of big rock in there to hold that up? They just put it right over dirt. Looks like to me, right? I mean, look at that. It's all dirt. I mean, where did all the big rock go? They didn't have any big rock. They poured a slab over just plain dirt. I don't see any gravel or anything in there. All right? And there's one big rock. I mean, there's no footer or anything. You put some sort of base gravel down, right? They didn't do anything. Huh?
And that's basically the only way to fix it. See how big the problem is, and then design a repair based on how big the problem is.
Try to see the extent of this.
Yeah, you need to manage the water, otherwise the problem will just be deep, right? Yeah, you're gonna have to. No, you wanna relieve the. Yeah. So basically, the problem is if you cut the water off here, you're going to have pressure up in here, and it will find another way out. Right? Yeah, you're right. Yeah. So what you really want to do is put a drain in that filters keeps the soil in place, but gets the water away. Right? So.
Yeah.
Yeah, you just want to get the water away safely. So. Pipe it out, filter it here, remove it, keep it measured so that you can tell when it's changing, and you compare that to the lake level and all that, so you can tell. There probably is some variation with lake level, but is it getting worse over time? Is it accelerating,
years and it hasn't really.
No, it's probably found a solution channel in the rock is probably what it's found, and it's probably gotten as big as it did. But the actual flow itself.
Kind of monitor the flow and we're running about the same.
Yeah.
So,
I mean, it's somewhere. Who knows how long the path is?
Yeah, we think we're starting over there.
Yeah.
All the
Yeah, there's no telling where it goes. You know, you could chase it for years and never find it. So a lot of times
We did the scientific water witching.
that was George's idea, not mine.
so Glenn, you don't think we should try and plug this?
well, cutting the flow off, you can try to cut the flow off up the stream. Success is questionable at best, right?
Finding where it's coming out is the problem.
Yeah. So the
The only way you can stop it, or I've found in ponds, is you got to be on the inside
Yeah.
to stop it. You can't plug it on the outside.
yeah, so on really big dams, you know, a lot of times they'll look at stuff like cutoff walls and stuff like that, and that's major excavation into the embankment.
Yeah, Marilyn was mentioning that cutoff wall all the way down.
Short of something like that, your best option is to manage and safely remove the water so that you don't have it doing stuff like this.
Yeah.
You can also monitor that flow, and you'll be able to tell if you've got a bigger problem developing because the flow is increasing a lot or it's getting.
And that's what we've been monitoring, yeah.
So,
That's what we've been trying to, that's what I was talking about this morning.
but you got to do that in a way that you have to design that drain in a way that's not going to allow the soil to keep moving, right? You want to keep the soil where it is and filter that and just get the water out so you get that water pressure out.
Keep the dirt back.
Yeah.
As long as we keep the dirt there.
But long term, you guys are putting cutoff walls in other dams.
Well, every site is specific. Its design is specific to the situation at the site.
And-
That's why your engineer, you know, you design it or you all
Ron,
get a
this
consultant.
is not the dam.
You get a consultant.
No, I know, but she said a cutoff wall would go from here all the way through the dam and to keep the water off. That's what they're doing in other
Well, all
places.
you need here is geotechnical
That would be
work.
over there.
Yeah.
Well, I said it starts here. I mean, it would block this. That's what Marilyn was saying.
I don't know.
Yeah, the geotech guys are the ones that do the filter gradation. And the Corps and, you know, NRCS, they all have specifications for filter materials and all that kind of stuff.
Since this has gotten worse, does the spillway then get a lower grade? I mean, you got to.
Well, this will cause the dam to have a poor condition assessment. Now, but it's important to note that that condition assessment is not indicative of the safety of the dam itself. It's more has to do with maintenance, conditions of documentation, conditions of the dam itself. Yes, this is something that needs to be fixed, but the dam's not in danger of failure.
Okay, good.
You know, I mean,
Good.
your biggest risk here is you're going to continue to degrade. You know, it could lead into an issue where there's an issue, but right now you're not, you know, I'm not, oh my goodness,
Drain the lake and what's
you know,
going on.
we have to lower the reservoir right now. You know, that's not the situation that you're in at the moment.
Yeah.
This is very much a monitor and repair, and you know, the cabinet stance on this is going to be, this is an issue that needs to be fixed.
Yeah.
And you all need to get an engineer in here, and you need to develop a corrective action plan. I can tell you what the letter's going to say. It's going to be written in the letter.
Yeah.
Get an engineer in here to assess this situation and develop. Right now, it's going to be develop a corrective action plan to submit to us. Say this is what we think we need to do. This is the timeline we think it's going to take.
Gotcha.
And then we're going to say, yes, we agree that that's what needs to happen, or no, we don't agree. We think this additionally needs to happen.
Yeah.
We need to change this. And then what your engineer will do is will develop the design. Then you'll submit the design to us for review and permitting.
Gotcha. Yeah, it's going to start with engineering, taking core samples and stuff like that.
Yeah,
Yeah.
and, you know, we'll probably say in the meantime, while you're getting all that lined out, we're going to want a quarterly inspection by your engineer saying, yes, it's getting worse, or no, it's not getting worse, you know, that kind of a thing.
Okay.
And that's just to help us keep track of it in the interim. Yeah.
Now, is that specific to just this, or you want to go ahead and talk about everything else?
We got to do the rest of the inspection.
But the spillway, this is the focus of your corrective action.
But that's pretty typical. I mean, I think, like I said, you've all been doing that previously, so.
Glenn, these other cracks aren't of concern?
Concrete cracks, so as long as there's not differential settlement.
Well, but our engineering analysis needs to be on this flow right here, on this big.
Yeah, well, that's the main thing right now.
Yeah.
We have to finish the rest of the inspection.
A lot of that's construction joints.
Yeah.
Those straight up and down ones are construction.
Yeah. Oh, but they leak.
Well, I'd have them assess the whole structure. Yeah.
That's what.
Okay.
Once you get the engineers here, you'd want them to kind of take the whole picture.
What's your name?
Jim Malott.
Oh, hi, Don. I'm trying to get a hold of you.
Yeah, I saw your email, and my wife's real sick, so I've been having.
Oh, sorry to hear that. Sorry to hear that. So when was this thing done? This thing was done in 17? Do you know? Were you involved in this?
I was started getting involved around.
Well, this is a mess, Jim. I mean, they just 8 years ago, this thing should have lasted longer than 8 years. I'd say they didn't put any substrate underneath there. You know? I mean, it didn't wash down because it wouldn't have. I mean, he should put some big rock in here and some little rock. You don't think? I think so.
The big rock just makes it hard to compact it, so you don't necessarily.
I think he put. When you say, Bruce, he put a slab of concrete right over dirt. Whoever did this. These leaking cracks aren't a problem. Something's going on there, you know.
It's water under the slab and it's issuing out through the cracks.
That's not a concern.
As long as there's not movement of the slab or
Like that, yeah.
the water's going to go somewhere. When it gets under the concrete up there through the rock, and then builds up some pressure underneath of the slab, and then he finds the path of least resistance to come out.
Yeah.
So, you know, a little bit. This would be more of a just monitor for changes.
Yeah, I want to see if it drops, see if the concrete drops.
Seeping like this is not really a concern. If we were to have larger discharges, muddy flow, that kind of a thing is what we're
Okay.
kind of looking for.
And we've got another crack here. So this thing doesn't need to be replaced. We'll monitor it. Over there.
We would probably recommend, you know, the engineer would most likely what we call sound it, just to see how what they can use hammers and listen to the sound.
I see.
And analyze the underneath.
Right. Right.
Through GPR, ground penetrating radar stuff.
They don't need to drill a hole here on this side of the spillway.
Well, they wouldn't drill a hole first thing. They would try to do non-invasive tests first.
I see. Yeah.
Drilling a hole is a can be done to inspect, but that's more invasive. You usually will do the non-invasive methods first, and then if you need to elevate to an invasive method,
Right.
you do that.
I got you.
So,
I got you. Huh. It's good to know this isn't a big issue. Yeah, look at that crack. I mean, that's that's massive. You know?
yeah, I mean, concrete cracks, so it's just the natural thing that happens. What you're really looking for is settlement, movement, you know, and of course, you know, you can get a void. That is an issue.
Yeah, I think they put that right on dirt. They put that slab. They didn't put any foundation underneath
That
there.
void is also in a section that's an armoring section, so that's the side slope of the spillway channel.
Yeah.
And that concrete is there to armor that against the flow from the spillway. So that area needs to be repaired, but it doesn't appear that it's compromising the integrity of the spillway itself.
Good, good. It's just water's coming down.
Yeah.
Underneath it.
The water's finding a channel, a solution channel through the rock somewhere, or through the soil, and it's coming through and around.
Yeah, but still, you don't lay concrete on dirt. You put foundation down, I think, right? I mean, that's whether it's load bearing or not.
Yeah, well, it depends on the design. The engineer will have to design the actual what goes back.
Well, I guess the other thing is that was done 8 years ago. This was done decades ago, I guess. The stuff that's holding has got rebar in it. That was done recently. But the one that dropped is old.
Mm-hmm.
That's the way I understand it. Still. Yeah.
There appears to be several different areas of repair in here. So.
Yeah, I don't know. Yeah. Okay. Wow.
That's 36.
Any problems there? No. You think they all going to leak like that? The valves are all going to leak?
Yeah, I mean, especially with the age of the valve, metal on metal sig, it's never a perfect seal. So a little bit of leakage is expected.
That's acceptable there?
Yeah, that's not an excessive amount of leakage.
Okay. It's just you wonder why, you know, we've got problems with algae and things. Now we know why it's leaking. It's leaking over there, but
There are more sinkholes
we need to measure the flow.
than there are damp, so that's an issue.
You know, Marilyn, you think we should measure the flow of that leak that's underneath that concrete there to see if it's, and then measure it periodically?
Now, right this minute, they need to be getting their funding together and measuring the flow is not the problem as much as how do you stop it?
Well, do we want to stop it, or is it's going to flow? It's going to leak.
It's got to be controlled.
Yeah, controlled.
If you don't stop that, then you're going to keep on losing your spillway.
Yeah.
The whole thing with seepage is controlling the seepage.
Right.
Not, at least through an embankment, it's not stopping it. It's how you control it.
Lucky come up
Yeah.
They injected grout in all these areas here. Trying to stop this.
Go ahead, Marilyn.
Some. Put a lot of stuff in there.
What you don't want, what you do not want, is material coming out of the dam. You want to build filters and drains so that the material does not come out of the dam and make a void inside the dam itself.
Right.
So,
Which is what we've got over there.
well,
We've got a
right
void,
there
don't we?
you do.
Yeah.
So that's on rock. So you're not talking about a piping failure.
Right.
Well, now did you look at all the nice videos and
I did.
were they amusing and entertaining?
I need to go through them again. You know.
So we're talking about piping failure, we're talking about water coming through the embankment and taking the soil out.
Right.
You don't want that to be happening. Once
Which-
the water starts coming out downstream, then it works its way back upstream. And then you eventually get a void.
Which I think is what's happened here.
No, that's not what's happening there. What's happening there is you got rock that is thin and weak, and you got some soil. And it is leaking, but it's not causing a piping failure.
Okay.
Go back and look at piping failure versus some other things.
Okay.
Yeah, that thing is sitting on some rock strata that's not very good. It's layered.
Yeah, you said that
And
the other
water
day.
comes out through the rock layers. And it's weak. And there is some soil there, but that's not a piping failure like you would have back over here in the embankment.
Right.
That would be water's coming through the embankment, it's bringing soil. Once it exits downstream, then it starts head cutting back. Then you get a void.
Continue to monitor it.
Get a void in the dam. You don't want that.
Yeah.
So the way that we control that on an older dam is generally with filter, so that you filter out soil particles, and you do that with what we call a drain blanket.
Drain blanket.
So you flatten the slope. We put in some drain pipes, perforated drains along the toe of the dam that will pick up the moisture, will carry it away from the dam. Then the drain blanket is usually a sand filter, then with a soil shell and grass over it. So not cheap at all to do, but it does work.
Kind of comes through down there. What we call the deep leak.
The filter will catch the sediment.
Do you have any idea about where the pipe
Catches the sediment. You
comes
don't
through
want the
the dam?
sediment coming out. You want it to stay in there.
Okay.
So
over that way?
the filter blanket will catch the sediment, and the perforated pipe acts as a drain to catch the water and take it away from the dam, and it will exit downstream from the dam through a
Yeah.
pipe and a head wall.
Oh. Look at this skull. That's for a big catfish.
Who's pouring all those rocks up the maintenance shed?
Now he's putting
side of the road. Pipe right here.
Okay, so what we're looking for here is good grass cover. You're looking for erosion protection along the shoreline. You've got that. It's regrap. Will prevent erosion.
Yeah.
Yeah, walk across. No, no,
Just
just put them
like
on the ground, just like this. Now, do they tingle?
No.
What do you guys do?
I'm messing
Hey,
with it,
hey,
Marilyn.
Bruce. Hey, Bruce, are you dousing? Is
I'm
that what
messing
you're
with
doing?
it.
Bruce is a dowsing rod. Not these guys.
Pulled out 25 years ago
I got this now.
because they were all eroding around and everything. And put it's just a wooden one, but that has not changed. We just redid it because it eroded around again. Did that, and then there's one down here in the lead.
Dad couldn't. So it ran on the fencing side of the fence. All right. Back off here.
Pretty good riprap, huh?
That's some good riprap.
You like that? We finally did something right, huh? Riprap. Here's a.
It's not going anywhere.
No, I like riprap
That's
better
just
than.
drain pipe.
I like riprap better than concrete walls, don't you?
Well, it doesn't cost as much, less maintenance.
Yeah. Seems to hold up better, you know. But we do have that leak. There's groundhog over there.
I let him mow it one time. He's different.
So this pipe just drains into the lake?
Yeah, he doesn't see much difference.
No, I don't see much difference.
That's kind of my feeling.
No,
My gut feeling too.
I don't see much difference. I think there's more damage over there.
Well,
On the far side of
that's
Spillway,
new to
but
me
the
too.
dam,
I
not,
had not seen that before.
not the dam.
That's come up.
Yeah, that should be fine.
I'll tell you something.
The only,
We started a campaign against, and that is utilities on dams.
Oh, right here.
Poles and, yeah,
Bad.
It's his size.
bad. Yes.
Interesting. Well, we got 1, 2, 3 poles, 4 poles, 5 poles on this dam. Yeah, but they got to put the pole somewhere, Marilyn.
Well, you don't want to be drilling in your embankment.
Yeah.
Then these things will extend under the embankment 6 to 8 feet. And you don't want that stuff going on, so. We've been having some conversations with Kentucky Utilities about doing that. They don't ask anybody's permission either. They just come out here and
Which ones can?
drill and put them in.
Oh, so they're allowed to put a pole anywhere, right?
Well, they think they are.
Well, I'll make a note of that. We gotta.
And you don't want water lines in your dam. You don't want gas lines, sewer lines.
I bet the water line goes through here too.
Hello. All right.
State inspector walking the dam. That's Marilyn right there. That's Glen way over there. It's Thursday, the 23rd of April, 2025. What'd you say, Marilyn? Didn't hear you.
Thinking out loud, whether somebody's hunting deer or whether hunting.
No, that's the hunt club over there.
Oh, okay.
There's a shooting.
They got a range?
Yeah.
I think there is a deer season open and squirrel season's open, so.
I mean, this thing seems to be leaking a lot, you know?
Well, that's not seepage.
No, I mean, not right here, but I mean, down there and then under the spillway, you know? Yeah, the good news is I don't see any slips.
We're keeping it mowed, and that's good.
Yeah, you taught me that anyway, that you mow it so you can watch for slips.
You mow it so you watch for that, for ground mugs, for burrows, for anything that's going on.
Yeah. 3 times a year is the regulation, I think you said?
It's not the regulation, it's what we recommend during growing season.
Yeah. So every other month from April.
Winter is pretty much normal.
Yeah.
And this has improved a great deal over the last few years.
I mean the grass?
It has.
The grass has?
The grass, but the maintenance overall.
Yeah. The cutting of the grass has improved, you're saying?
I'm saying overall maintenance has improved.
Well, I don't think we've done anything other than cut the grass and fill some potholes. Saying is that?
Dude, the measurement
Well,
manually is
That riprap has not always been on the
when
upstream
it gets
slope
some
like
water.
that.
Oh, I see.
And then the cable has foot markings on it. Tells you how deep the water is in the dam, and you know what the top elevation is. You do the math, you know what the water elevation is down in the dam.
What's that pipe here for?
test water level in the dam.
Really?
Yeah,
We ever used it, Bruce? You know?
they're pretty old.
It's probably filled up.
Well, and they're very old, so they may or may not be functional anymore.
Test the water level.
Yeah, it tells you what the surface of the water's doing inside the embankment.
I'll be damned. We ever use that, Bruce? Do you know?
Not that I've ever seen.
Huh.
It's a piezometer.
It's called a piezometer.
Yep. Some of your Brady videos will probably tell you about that.
That's the piezometer right there. Test the water of the dam. Probably never used it.
Go shoot the other direction.
Yeah, son. This leak, this bothers me.
This has been here since 1960.
I don't think so.
Ain't got any worse. Yes, it has.
How do you know? I mean, this.
They've measured it since 1960, since they built the lake.
Somebody put a little bridge there. Look at that little stop. I guess to measure the flow, that wood bridge.
That's what we're looking for.
You've never seen it cloudy around here.
Yeah.
It's always been clear water.
Was it cloud? No, it's pretty clear, isn't it?
Yeah, that's a good thing.
So this
That weir box knows
this
that.
is new. It's been here for
Did we ever take a measurement on it?
up in here, but
I'm not the engineer.
That weir used to be
That
like
V
up
and that flow is how it's calculated.
No, well, a long time ago, those concrete ones that were there, and there was a pipe running in, but it had all grown over and eroded around it and everything, and the flow in that. So we did this, which is not a scientific, but it gives you an idea to gauge. You know, we can gauge how much it is. You know, if it's coming up or down or that. And we had
Should we ever try and stop this, Marilyn?
You don't happen to know when
No?
the last time that valve was open, do you?
Should never try and slow this thing down? This is normal?
If this is coming out of a spring up the hill somewhere,
there was a
You
concrete
don't need to
thing
mess
came out
with
the
it.
lake
It's
where
coming
Bruce
through
was
the
saying a
dam.
riser came out.
then what you're
When the
gonna
lake was
have
put in,
to
it was
do
leaking always is what
is
I was a little
engineer
baby.
check it out, find out where it's coming from,
Yeah, but
and determine what to do with it.
destroyed it, tried it because it was leaking around the valve coming down. And forever.
I mean, it looks like it's leaking from.
Could to stop it from leaking around it. So
Is the pipe still open into the dam, or is it, did they grout it?
They sandbagged it. Lee told me that they never could stop it. They went in and sandbagged it, couldn't stop it, and they put an explosive in there. Sandbagged it and boom, and it stopped it.
So yes, the pipe is still there. And,
yeah, but if you opened it, if you ever get it
I
out.
think it's exposed on the other end,
Yeah,
other side of that
yeah.
dam. It's got to be buried.
yeah.
And it's only about 32 feet on the other side of that dam at the deepest part.
We just note that it still has reservoir head on its main.
Yeah, right. Yeah. But this leak here comes from all the way up there at the natural seam and the seam between the natural earth and the earthen dam. Yeah, and we know that because we can put dye up there and it's right down here and a little more than that. Yeah, pretty quick. Yeah, it's running the same. Yeah. Maybe just there's another weir. Yeah, and it never eroded around it. Yeah, but it's maybe just a tiny bit. Yeah. Yeah, this one, and we moved the weir, but the screw, even when it filled back up behind it, the screw's exactly, water's running the same, because I mean, that's just, measuring it.
Where'd you get those things out of there? Is that a concern, Glenn, this thing here?
As long as it's not changing, it's more of a monitoring. And that weir helps them monitor the changes.
Well, I think it's coming from underneath the dam, right?
I couldn't tell you where it was coming from. I could only offer supposition. Most likely through the rock.
Yeah.
Given the age of the dam, there wasn't a lot of foundation treatment when they built, the dam.
They got a drywall screw right there to measure the height of the water. See that drywall screw right there? It's like they got a drywall screw to measure the flow right there.
Yeah, I did that, Donnie.
That's a good idea.
That's flow. The air and the stream the other one. That way I can come down here easily. And
yeah, that's a good idea.
And see how much it's changed.
Yeah. Has it ever changed?
This one here never changes, except when the lake goes down, it'll be about half of that.
Yeah.
Because it's a high lake.
So basically what you're looking for here is major changes in flow volume, unexpected changes in flow volume.
Right. And I drive down here probably I want to say every month, but it's probably at least every 2 months.
Muddy flow.
Yeah. And when I drive by up top and look at it. I got binoculars now, but I come down here probably every 2 months and look at it. This is your side and consistent like this, at least since we measured it, probably at least 15 years and probably 30 years. I mean, this is a constant. It's done its stuff through the rock, and I think it's staying where it is.
Yeah, you call this a leak. You want to see what the leak is.
Call this a leak? Is that what you said, Glenn?
200 gallons per minute.
It's a leak.
We ever tried to plug it?
But I mean, the flow is
We haven't really tried to do much up there.
fairly clear.
They were up there. They went up there and drilled some pipes and tried to put some grout in there one time, but they couldn't.
From my
couldn't get it down
recollection,
there.
it's about the same as it has been. I mean, I haven't been coming to
Right.
as much.
It is.
It's all both these and that one, but it wasn't that way.
Does the lake naturally go down during dry times?
So what I was doing, I looked at, it's like maybe 3/8 foot day at the worst, 3/8 of an inch. And I figured about a quarter of that was probably out there. I'm talking about like when it's August, that's when it was out. When it really got hot.
And that was all it was going down?
About I was getting about a couple inches a week.
Yeah, a lot.
So the worst I'd measured was down about 14 inches this year at the worst of it.
some fuel. Last year, I got down closer to 19, but we had more drought last year too. Not this past year, but the year before. Well, not this past one, but the same before that. We had a longer stretch, almost a couple months in there. And we had a lot of rain in the spring and early in the after July. That was starting to affect it.
Yeah. So I think what we'll say in our report is when you had your geotech come work on the spillway, unit repair concept like that, we could recommend engineers to
I've worked with engineers for not in 18 million before.
Yeah. We'll probably add to have them do an assessment program, maybe a filter collection on this one. Yeah.
I did a food one down here. I took the jars and just took the water out, took the mason jars, and we put it out to see. I really didn't get much of anything in there.
What would have
kind of sediment transport? There's a little bit.
Yeah, it's almost like it's pretty clear.
I mean, that's very clear there.
Yeah, and it's the same way with the other one down there and the beetroot. So I was feeling that I wasn't losing a lot of material.
No, I don't see signs
it's the water.
I don't see any signs of significant material transport.
Yeah.
There's a little bit, but a lot of that could just be some lagging hands too, where it's stirring it up.
What would a filter do?
So I was getting.
That would prevent any kind of material transport.
We put it here, or we have to dig up there?
I mean, you would usually put it right at the outlet.
I'm just trying to keep the fines from going through.
Yeah.
Let the water go out.
Then you gotta, does the filter, will it back up, I guess, and once it gets clogged? But
A properly designed filter will have a multi-decade service life.
okay.
That's why the proper gradation is critical.
I mean, this flow is about the same as over there under the spillway. This is where all the water is going.
Well, I think we have 200 gallons per minute. It's a total of about 600 gallons per minute with all of this.
Really? 600 gallons a minute.
Per minute.
That seems like a lot.
Well,
you know?
the lower the lake, I think it was like 740,000 gallons or something like that to take it down a minute. You know?
Yeah.
I mean, don't quote me.
That's over 100 acres, isn't it?
We're 240 acres.
Yeah, it takes quite a while. That's a lot of water.
A lot.
Yeah.
It might have been 1.4 million. I have to go back and look at it.
So this is a nit, you're saying?
It's like
in volume terms.
Because you know,
it sounds like a lot.
Yeah.
When you think about the total volume.
Yeah. Probably lose more from evaporation,
well,
I guess.
Rule of thumb on a hot day,
amount from evaporation.
about a quarter inch or so.
200
a quarter inch. A quarter inch of loss per day. With the sun, that's a nice kind of
in summertime?
Yeah.
Quarter inch?
Hot day with some wind.
Quarter inch of loss of. Okay.
Just from evaporation.
Yeah, I think our take right now is going to be continue to monitor.
Yeah.
And potentially propose a mitigation measure like a filter or something, I guess. Yeah, I think that's
not required. You're not going to require a filter. You're going to say maybe a filter. Is that what you're saying?
We're going to require a corrective action plan developed by an engineer.
Okay.
They're probably most likely going to propose some sort of filter.
Okay.
That's what we need to kind of respond back to you.
Yeah. In the interim, you know, and of course, in the interim, it's just a monitor and report. If it's staying the same, you know, the schedule can be, we can work on the mitigation. Yeah, you know, as long as we don't see a worsening situation, that kind of thing.
You don't see something dire like it's going to next week that really needs to damage. It feels kind of stabilizing.
You know, we definitely would recommend an emergency action plan. I know Marilyn's been talking to you about that.
Yeah. Sherry said we had one. She said she developed one. So, yeah, but we need to.
Currently required. and I won't speak to any future requirements. So
Oh, it's not required. It's a recommendation.
it's not required yet.
Okay.
But it's very, very highly recommended to all dam owners that find significant hazard dams that they have an up-to-date emergency action plan. And basically that just lets you, when you've got a situation, you don't have to be sitting there thinking about, you can look, got your procedure written down, and we're going to call these people, we're going to take this action.